So let me share my screen. All right, so let's talk about closure today. So, and actually let me back out so I can zoom out of this. Okay. So today's lecture is incredibly simple. We're just going to talk about returning functions from functions, as well as the idea of closure. We won't talk about the bonus. It's more of a nice to know, but it doesn't necessarily fit with today's theme. So just we're going to concern ourselves mostly with the first two bullets for now. Okay, so the first topic is returning functions from functions. Hopefully, you can kind of see where we're going with this. One of the things we've harped on, since day one in this curriculum is just everything in JavaScript is a value that can be used. It can be passed back and forth. It can be stored. It can be recalled. It can be, you can do basically a lot of things. And one of the things that we've also talked about is functions are just like any other variables. So what does that mean? So if I have a function here, if I make a function here called returns a string, this function takes in no arguments and it simply returns the string, I am a string. Now, if I if I run line 7 and I say let return value equal returns a string, what does that actually give me? Well, if we run returns a string, and notice how we are invoking returns a string, notice the open and close parentheses after line 7, that means we're running returns a string. We're going to see whatever that function returns, in this case a string, and we're going to store that string in the variable called return value, right? So when we console log out return value, we get I am a string. So hopefully this is review, and this is something that you're very comfortable and familiar with. But let's now add one extra wrinkle to it. This is not very new, but let's take a look at something like this. Here on lines 1 through 3, we've created a function called greetme. And so far, all the function really does is it console logs out the string hi, exclamation mark. Okay, that's the entire function. On line 5, we have another function called getGreeter. And in this function, what we do is we return the greetme. Notice how we're not calling the greetme function, right? Because on line 6 there, after greetme, there's no open and close parentheses. That means we're not invoking the function. In fact, all we're doing is treating greetme as a variable, which it is, right? It's a variable that represents the function we created on lines 1 through 3. If I look at just lines 5 through 7, I actually don't even know what data type greetme is, right? Greetme could be a string, it could be a boolean, it could be a number. Looking at the variable itself doesn't tell me what I'm looking at. But in this case, because I am able to see lines 1 through 3, I know that greetme represents a function. So on line 9 there, when I invoke getGreeter, and once again, I'm invoking getGreeter because we see the open and close parentheses after getGreeter. What that does is that runs greetme. That runs getGreeter, which then returns greetme. Okay, and then we store that greetme value in the greeter variable on line 9. So if I console log out type of greeter and I console log out greeter, I get back type of greeter is equal to a function. If I console log out greeter, it says function greetme. That's just how console log prints out functions. Those square brackets does not indicate it's an array. That's just how it looks to us visually. And then lastly, on line 13 there, what we're doing is we're actually invoking greeter. But when we invoke greeter, what are we really invoking? Well, once again, based on line 12, it tells us greeter is the function greetme. So when I invoke greeter, it's the same as invoking the function greetme. And when I invoke the function greetme, I console log out hi there on line 2. Okay, so all of this is a roundabout way of showing you. In the previous example on line 6 there, we were returning a string. Now on line 6, we're returning a variable, and that variable happens to be a function. This just goes to show you that, and just another way in which a function is just like any other data type in JavaScript. We can store it in variables and we can pass it back and forth. The only really special thing about the function in this case is not only can we pass it back and forth, but we can also invoke it. Right, we also run the function. So here on line 6, once again, we're actually returning a function from the getGreeter function. A little bit confusing, yes, but if you think of if you don't think of functions as kind of some special unicorn and just think of it as another data type, then hopefully this should come fairly intuitively, because we have been doing this for the past few weeks, except we've just never used we haven't returned a function yet, and now we are. And I'm also kind of letting you know that when you return a function, it's the same as returning anything else, as it's the same as returning any other data type. So here on line 1, we go back to our greet me function at console logs out hi. But now here in the getGreeter function, notice how we're still returning greet me, but we're actually not returning the function itself. Notice how on line 6, we have an open and closed parentheses after greet me. So what that means is we're actually invoking greet me. Greet me is going to return something, and we return whatever greet me returns after we invoke it. So here on line 9, on the right hand side of the equal sign, we're invoking getGreeter. Okay, it's getGreeter with an open and closed parentheses. So that means we then run line 6. Line 6 says, let's return whatever greet me returns when we run it. So that requires us to actually run greet me. And so what does greet me return when I run it? Remember, console logs and returns are fundamentally different things. Console logs are purely for human consumption, whereas returns are values that's actually being passed back to whoever called it. In this case, when we invoke greet me on line 6, we actually console log out hi, but the function doesn't return anything, right? There's no return statement in the greet me function. And so just to kind of remind you one more time of, if a JavaScript function does not have a return statement, then by default, that function is going to return undefined. Okay, so I'll say it one more time. A function in JavaScript, if you don't tell it explicitly what to return, by default, it will return undefined. So in this case, when someone invokes the greet me function that we made on line 1, the function doesn't return anything explicitly. So therefore, implicitly, it is going to return undefined. And so that's going to return undefined. And on line 6, we're saying, hey, return whatever greet me return. Well, greet me returned undefined. So on line 6, we are also returning undefined. Okay, and so once we return undefined, who called getGreeter? Well, we called it on line 9. So the right hand side of the equal sign becomes undefined, and then we are storing the value of undefined in the greeter function. And then lastly, you'll notice the last error that we see. We were trying to do what we did earlier, which was make the assumption that whatever variable we have with a function, but when we try invoking it, we try invoking greeter, because we thought there's a chance it might have been a function, we get back type error. And so this points to another fundamental idea in JavaScript, right? Which is that computers actually don't know what you're supposed to want to do. So how a computer usually checks for errors is it will try to do the thing that you ask it to do, and it'll tell you if it fails. In this case, on line 6, right, when we return greet me, there's nothing that JavaScript says, hey, this has to return a function. In fact, JavaScript has no opinion on what greet me is. It could be anything, right? And so then when we store it in greeter, JavaScript has no opinion once again whether that's correct. It is only when we try to invoke greeter as if it's a function that JavaScript says, hey, you actually can't invoke that because you're not a function. And so that's probably the first time that we actually see this error come to surface. So once again, just because your code does not break, it doesn't mean that it's working correctly, right? JavaScript will not break unless you try to have it do something that it cannot explicitly do. And then lastly, this is a very similar idea, except now notice how we're creating the greet me function inside of getGreeter. So on line 10, when we say let greeter equal getGreeter, on the right hand side we're invoking the getGreeter function. When we invoke the getGreeter function, what does that do? Well, on lines 3 through 5, it creates this variable called greet me and assigns to it this function that console logs out hi. And then on line 7, we return the greet me function. So therefore, on line 10, the right hand side of the equal sign becomes the greet me function, and we store that value inside the greeter variable. So on line 11, when we actually invoke greeter, we get back a console log of hi. So this is just showing that it doesn't actually matter where we create the function. We could create it outside of the parent function. We could create it inside the function. It doesn't matter where we create greet_me. As long as we have access to that function, we are able to return it from our function. And this is the last part of this segment, which is to say that when we create a function, right, we can either give it a name like we did in the previous section, right? We can create a function and call it, greet_me, or we can also return an anonymous function too. Here on line 3, hopefully I think you've seen this syntax quite a bit in Elliot's review videos. This is just what we call the arrow syntax. It fundamentally is just creating a function as well, and we could or could not use the function for this. If we didn't, let me just type it out so you see what it looks like. Cool. So we could also just say return function this. All right, so these two are the same thing. In both cases, all we're saying is, hey, we don't actually need to create a variable or create a function, store in a variable, and then return the variable. We can actually just say return and then just create and return the function right away. So when we do this, this will also console log out hi when we run to it, because once again, this is also returning a function. So to further extrapolate on this, because we're returning a function, well, functions can also take in arguments too. So here, all we're saying is, hey, if I return this function that takes in a name and a console logs out hi name, when I store it inside greeter, that just means going forward, whenever I invoke greeter, it's the same as if, in this case, as if I'm invoking that function that I create on lines 3 through 5. And so if that requires a name, then when I invoke greeter, I'll also give it a name, and it'll console log out that name as well. And once again, on line 12, we just want to remind you that if a function is expecting an argument and we don't give it an argument, the function won't break. It will just, by default, assign that parameter to the value of undefined. Okay, so any questions so far from this segment? Right, all we're basically telling you is treat functions like you would any other values. You can use them, you can return them out of other functions, etc. There's nothing that makes them special in this regard. Any questions at all?
So does the return statement, is it like when you assign a variable with an equals sign? Is that what it's doing with the function? Like it's setting the function equal to the value of whatever work it did within the function?
The return statement is not doing that. If I understand your question correctly, you're asking something like, let's say I have a function I call David, and this just returns hi, right?
Right.
This is equal to saying something like let David equal function. So these two are synonymous. And so if I was to have something here that says return David, this would say David is a function, and then this would also say David is a function. So that's what these two are doing. The return statement is separate from assignment. Return just says, so if I was to have a line that does something like this, this basically says, hey, create a function and then return it right away. Just like how if I say return David, this says create this string and then return it right away.
Okay.
Right. So there's no assignment here. In returns, returns do something very different than assignments. Assignment is when you're trying to store a value in a variable. A return statement is more like I'm just giving it back to whoever asked for it, and I don't know what you do with it. Right? Whoever you give it back to could choose to use it. They could choose not to use it. Return doesn't validate any of that. Whereas in order to use an assignment operator, you need something to be storing it to. Okay, cool. So then let's move on to closure. So what is closure? So this takes us back to the section we did on scope. And if you remember, basically how scope works was not every function has access to every other variable on the page. In fact, and let me know if any of this sounds unfamiliar to you. The basic premise of scope was you are able to access everything in your own scope, and usually scope is defined by the open and closed curly braces. You are able to access any variables created in your own scope. You're able to access any variables created in your parent scope, but you are not allowed to access any variables created in your child scope or your sibling scope. Does that sound familiar to you at all? Yes? Yes? Okay, great. And so when we look at the function here, this is exhibited in the idea that we have on line 6, we create a function called greeter. On line 7, we have a variable called name, we set equal to Marie. On line 8, we have a variable called says hi, we set equal to a function. And notice how when we execute we invoke says hi on line 11, right? Because on line 8, all we're doing is creating a variable in a function. We don't do anything with it. On line 11 is the first time we actually invoke that function. Notice how when we invoke the says hi function on line 11, what that does is it invokes a function. It takes us to line 9, and we console log out hi followed by the name variable. Now, within the says hi function scope, there is no variable called name, right? And that's where JavaScript is always going to look. It's going to look in the scope of the function first and say, do you have a variable called name? And the answer is no, there's no variable called name. So because of that, it then says, okay, does your parent scope have a variable called name? Well, what's the parent scope of the says hi function? It's the scope of the greeter function. So then JavaScript asks the greeter function, hey, do you have a variable called name in your scope? And the answer is, yeah, we do. We created there on line 7. And so because that exists, then on line 9, we would say, hi, Marie, right? Hi, comma, name. And so this is just a refresher to remind you of the fact that that we are able to look in our parent scopes for variables. Okay. So why does that matter or how does that apply to closure? Well, closure is the idea that the inner function, in this case, the says hi function from the previous example, it can still access values defined in its parent scope even after the outer scope is finished running. So that's a really confusing idea to think about. So let's kind of see it in practice. Here we have a function called getGreeter. On line 2, what it does is the console logs out getGreeter is running. On line 4, it creates a variable called Marie. On line 6, we say, hey, this getGreeter function is finished. On line 8, we return a function that this console logs out hi name. And then, sorry, I'm having trouble seeing my screen here. Okay, and then on line 13, we set the variable greeter equal to get greeter. Get greeter invoked. And so what happens when we invoke get greeter? Well, we run console log get greeter is running. We create a variable name set equal to Marie. We console log out get greeter is finished, and then we return this function, this anonymous function that just console logs out hi comma name. Okay, so that's what we get back. That function is what we get back on line 13 on the right hand side of the equal sign, and we assign that function to the greeter variable. So now when we invoke greeter on line 14, it's synonymous with us invoking the function on line 8. Everyone follow so far? Right? Because getGreeter returns the function on line 8 and we assign it to the greeter variable, when we invoke greeter, it's the same as us invoking the function we created on line 8.
Why does getGreeter stop before the return? Isn't that part of the function?
It doesn't stop.
Okay, I thought with the console log statement, it was saying that it stopped there.
No, so that's a good point. So the reason why I put the console log there is because if we put it after the return statement, it will never run, right? Because once the function sees a return, it stops. So this is maybe it's inappropriate for us to say it's finished running. We'll say, this is the last thing getGreeter runs before it returns and actually permanently stops the function, right? So that's the only place we could put it, but point taken, it is a bit confusing in how we're naming it. Okay, so on line 14 now, when we invoke greeter, it's the same as us invoking the function we create on line 8. And when we do that, we'll see, yep, getGreeter is running because we invoked it on line 13. getGreeter is finishing. Yep, we invoked that on line 13 as well when we invoke getGreeter. And then on line 14, you'll notice we say, hi, Marie. The question becomes, how is that function on line 8 able to access the variable Marie, right? Because one, aren't we out of the scope of the getGreeter function now, right? Notice how greeter on line 14 exists outside of the scope of getGreeter. So theoretically, based on everything we've learned about scope, the idea is we shouldn't be able to see a variable, in this case Marie, that was created inside the getGreeter function, right? So that's the first kind of weird thing that we're noticing. The other thing that we're noticing is, well, getGreeter is finished running, so isn't everything inside there kind of like done? How are we still able to access a name variable even though the function is finished running and we're not in the scope of the function? And so this is the fundamental premise of closure. Sorry, which is the fact that the inner function, in this case, that an anonymous function, that console logout name, that can still access values that was defined in the outer or in the parent function, even after the outer function is finished running. Does this make a little bit more sense now? If we take this quote and we apply it once again to our example, all we're saying here is that function that we created on line 8 there, that function has access to the name variable even after its outer function, or in this case, a getGreeter function, finishes running. So when we return that function on line 8 somewhere else, that function that we return, that can access a Marie variable whenever it wants. It doesn't have to be in the getGreeter scope, and getGreeter doesn't even have to be rerun, right? As long as it ran once, then we're good to go. And so the reason why we call it closure is this idea that the function, in this case, the function line 8, it almost encloses upon all the variables that it had access to when it was created. Okay, so if we take another look at this, if we take a look at another example, here we have the getGreeter function. Once again, it takes in a name, right? And on line 3, we return a function that console logs out hi name. If we do the same exact thing again, notice how when we do greeter, we get back hi Rosalind. Because remember, the name parameter there on line 2, even though it's a parameter, even though it's something that we take into it, remember that parameters are also variables that are being created within that scope. So that name parameter is the same as a name variable. And if we say that our function on line 3 has access to everything inside the getGreeter scope on line 2, that includes that name parameter. So that is why on line 8, after we do getGreeter, we pass in Rosalind, and we return the function on line 3, and we assign a value of greeter. When we run greeter there on line 9, that's the same as running the function on line 3. And once again, when we run that function, that has access to every variable it had access to when it was created, which in this case includes the name parameter. And so this is just simply another example of that, where it looks very similar to the previous example. We still pass in Marie as name 1 into the getGreeter function. And so whenever we run the function on line 3, we have access to name 1 variable. The only difference here now is the actual function itself, it also takes in a parameter called name2. And so when we console log it, we're saying hi name1 meet name2. Now, name1 is determined when this function was created, right? And so this was determined on line 8 when we passed in Marie to getGreeter. Because remember, name1 is equal to whatever argument is being passed into getGreeter. Name2, on the other hand, is determined whenever we call the function, whenever we invoke the function. And remember how we set the value of the function equal to the greeter variable on line 8? That just means whenever we invoke greeter, like we do on line 9 with Rosalind, that Rosalind becomes name 2, right? So after name 1 runs, as far as we're concerned, greeter will always think name 1 is Marie, so we can never change it ever again. But we can pass in whatever value we want for name 2, because name 2 is determined when the function is invoked, not when it was created. Whereas name 1 is determined when it was created. Did I lose anyone just yet? Okay, all right, cool. In that case, then here you'll notice how we have a few examples here. Same code as before, except now we have, rather than calling greeter, we now make two. We call get greeter twice, right? Every time we call get greeter, we're returning a new function, right? We're returning a new function from line 2. The one on line 7, the function that gets returned from that instance of get greeter, we invoke get greeter was Marie 1. So in that world, we'll say in that dimension, in that world, name 1 is equal to Marie. So when we return the function on line 2 and we assign to the variable introduce Marie 2, that function is going to think name 1 is always Marie. On line 8, we're calling getGreeter again, and that's going to return another function that happens to be the same as a previous one, but those two are those two are unlinked. And in that world, name 1 is Rosalind, because that's when we invoked getGreeter with it. We invoked it with Rosalind. So introduce Marie 2, that variable is going to have a function that thinks name 1 is always Marie. Introduce Rosalind 2 is going to be a function that always thinks that name 1 is going to be Rosalind. And so on line 10, when we invoke introduce Marie 2 and pass in Dorothy as name 2, or beneath it when we introduce Marie 2 and pass in Albert. Notice how for the output on line 10, basically all that says is, hey, you can invoke this function with whatever name you want, but you're only ever going to be replacing name 2. Name 1 is always going to be Marie from here on out. Similarly, for introduce Rosalind 2, name 1 in that world, in the world where that function was created, name 1 was Rosalind, and it will always be Rosalind. So we can say meet Barbara, meet Isaac, etc. But for that function, from that function's standpoint, name 1 was determined when it was created, and it was created in a world in which Rosalind was name 1, right, from line 8. So that's pretty much it, right? We talked about how we return functions from functions, which hopefully is very straightforward, right? We treat it just like we do any other variable. It could be a string, it could be a boolean, whatever. Just be sure that when you return a function, be sure you're very clear on whether you're returning the function itself or you're returning what that function returns. And to return whatever that function returns, remember you have to invoke, or you have to call the function, okay? And then we also talked about closure, which is this idea that the scope for a function, as in what variables that function has access to, that is determined based on when that variable was created. And even when that function is used outside of the scope in which it was created, it will still have access to all the variables that were in place when it was created, right? It encloses upon all those variables. Okay, so that's pretty much it for today. Very short lecture. Hopefully you'll get a lot of practice in. Before I wrap up here, any questions? Any questions at all? All right, cool. The workshop is now live. Let me break you guys off into small groups, and